Hi everyone, thanks for joining us. Hope you're alright. Alright. So, really excited to present this next video and upload it for you. It's something I've been working on, something I know a couple of you are quite interested in. Standalone ECU for the Chinese diesel heaters. Made a little bit more progress over the last couple of days. The next stage this is just a bench test at the moment, which I'm going to show you in a moment. The next stage will be to hook it up to the actual Chinese diesel heater and run some tests. I do have a spare diesel heater, which I will pull the ECU board out of and pop it into the come out into the garden with it, and we'll give it a try in the garden. We'll do a live test in the garden, and I'll record that first test so we can all see how it worked. So today is just really to show you the ECU construction, how I've built it, and how I've mackled it together, and how it seems to be performing on the bench. Spent a few hours at it. I'm not sure when I'll be able to run a live test, because those of you who aren't in the UK may be interested to know that the teachers are going on strike next week, and I still have a little one at school age, and it's going to mess up my free time, unfortunately. The lazy bastards have decided to go on strike, and apparently it's fine for your kids to miss a day or two of school when they're on strike. However, if you dare to take them out of school early to go on holiday or anything, we get fined. But that's, welcome to the UK. I'm not sure when I will be able to get out next week and try the live test with the Chinese diesel heater. But enough said, let's bring you around to the project and let you have a look yourself. Thanks very much for watching. Thanks very much for all the comments. I love the comments, thank you very much. Joel over at Lowered Expectations, he's doing some great stuff, really good videos. I suggest you go and watch his if you haven't already. Subscribe to him. He's doing some really interesting stuff. It really amuses me. He's doing some great stuff. He's working along a different sort of line as me, but I guess eventually the fact that we'll have full adjustment on this one, it might help what he's doing too. Who knows? So it's just something to mention. Thanks for all the comments. Please subscribe and like. That is important, as you know. I'm not doing this for money, I'm just doing it for interest, but the more people who subscribe and like, the more it gets pushed and the more it will be seen, and hopefully be of some use to people. Right, okay, let's bring you round. Right, back again. So this is it. This is the wonderful piece of kit. I'll just do a quick run through what's actually inside it, and then I'll pause the video and we'll come back. So we've got two timers there, any 555 timers, usual sort of crap, driving relays. One has a trigger start, but one just relies on DC to start. I had to mess around with the capacitor values of this one that had a maximum time of 10 seconds. I've added some extra capacitance to that electrolytic there. I think I've put another 200 mic on the back side of the board, and that's given me the time I need, which I'll explain when we start running. What have we got? That is a DC motor controller, very basic pulse width modulation type thing. You can't adjust the duty ratio of that one, so that one will be running the fan for the purpose of the test. Here is our fan. It's actually a window washer motor, but that will be, you'll have to use your imagination a little bit, and that's the fan. Okay, so this relay here is going to be controlling the glow plug, and for the purpose of our test, that LED there, which should light orange, will be our glow plug. This, for argument's sake, for information's sake, let's just call these two timer boards our ignition timers. So the first timer there is for the glow plug. The second timer there is to get it going. So this timer here then switches on the fan controller and the pulse generator here. The pulse generator has got, whoops, over there. This is the pulse generator board. I've had to mess around with that to get the speed control I wanted out of it externally. I've had to remove one of the multi-turn pots and then put another 10k pot in series with it. That in turn, pulse generator in turn runs this little MOSFET driver board. You wouldn't need to buy a board, you can just stick a normal MOSFET in it. I had a board, so it made sense to use it for the purpose of this sort of breadboardy type construction. This is a 7805 voltage regulator. Both of these boards need 5 volts to run. So after the glow plug's been on for a while, this board here will kick in and tell the fan to run. It will also tell the pulse generator to run, which will in turn run the fuel pump. When it comes up to temperature, or when the heat exchanger starts to see an increase in heat because we have ignition, this thermocouple, which will be on the heat exchanger, will tell this board here to operate. It's just basically an electronic thermostat. I've messed around with the values at the moment just for the purpose of testing. I am going to look at updating that or changing that, but again, I had a thermostatic board controller for an old car project. We were using it to do an electric fan driver, so it made sense to use it. So once this board, this relay clicks in, because it can sense heat happening, these timers eventually will time. These two timers eventually time out, and the relay in this thermostatic controller takes over the DC supply to these two modules. If at any chance we have a flame out and the famous thermocouple sees a drop in temperature, the relay here will then drop out, thus switching everything off. I think that's explained the operation. I don't think I've put anything else in there. It's worth bearing in mind that this doesn't have any monitoring of the fan movement. So although it will sense and switch off if there's a flame out, it's not going to sense and switch off if the fan stops turning. It's something I can look at. I'm not sure how important that is, but it is something that our existing controllers all have. I have blown up a few boards. Originally I had 2 of these boards, which are great. They're really versatile and you can adjust them from 0.1 of a second up to about, I don't know, an hour or something. But I blew one up very carelessly, so I had to resort to this board. If I was going to build another one of these, I would probably build them with 2 of these boards. I do prefer these slightly more expensive boards. They're only about £1 more expensive, and you've got much more control. Probably the downside of these 2 boards is that you do have to have a trigger pulse to start them off, whereas this one starts off fine on its own. As soon as it sees 12 volts across it, it will start timing down. The reason we've got 2 espresso cups there will become very obvious when it starts running, but basically one's going to have cool water in it and one's going to have warm water in it, so we can check the thermostat function. The oscilloscope is just monitoring I want to show you the duty cycle of the pulse generator while we're doing it. That's quite an important thing. Talking of which, when I run the test, I am going to let you hear the dosing pump start, but then shortly after I'm going to unplug that dosing pump, and you're going to have to use your imagination, and that LED there will be pulsing, replicating the dosing pump going. I don't want to keep on running that pump dry. I've run it dry a few times now, and I don't really want to have to buy a new one. So forgive me for that. I hope you'll understand. Okay, let me just pause this. So here we go. We're going to run the test. So we're going to switch the unit on. This LED here purely tells me that we've got 12 volts coming up to it. Obviously at the moment the thermocouple must be sitting at about 16.5 degrees, which is the room temperature today here. And we're going to start the thing off. So we've pressed the start button, and immediately you can see that the orange LED is glowing. That means that the or it thinks the glow plug is on. There's also an indicator there. Obviously in real life you're not going to see that glow plug, that LED. That's going to be connected to a glow plug, but the front panel will have a green indicator showing you that the glow plug has a power. So after around about, I think I've got it set for time for just over a minute. There we go. Now why is it doing that? It's just... So at the moment now the startup sequence is going, and you can hear the dosing pump. Off it goes. The LED is also flashing just to show you, and here are our speed controls. So let's imagine that that's our fan. I will be calibrating that against the ECU as well, and then we can adjust the pulse width of that. Obviously we're a bit low on current here, so you can see the display on the oscilloscope showing we've got 1 Hertz there, up to 3 Hertz. We can control it down to 2 Hertz. There we go, there's 6 Hertz. So, right, before I forget, so now we have to imagine now, we'll have to imagine now that things have started to warm up and we've got some heat going on. And you can see the temperature increasing. I'm just going to slow that down. So what the other green light on the left hand side tells me is that the thermostat has now sensed there's heat being generated in the heater, on the heat exchanger, and the green LED has now clicked in, and relays clicked in to take over supply of all the modules. Obviously in real life it wouldn't happen quite as quick as it just has, but this is just for their test. So the next stage, oh man, I've been covering up the LEDs, I'm sorry about that. So these two LEDs here are the glow plug and the start circuits, and this LED here is the telling me that the thermostat has sensed everything's up and running and we've got heat being produced. Right, that's the key bit. So now the ignition timers, for want of a better expression, have now dropped out. So this is running purely now on what the thermostat's telling it. If the thermostat's saying, yes, there's heat being generated, I'm quite happy to continue with the operation. So then all of a sudden the flame goes out. Flame goes out and we switched off. How about that? Right, well I hope you enjoyed that as much as I've enjoyed demonstrating it. I'm sorry I had my arm in a way to begin with. And also it's worth mentioning, I do apologise completely for the poor quality of the last video I put up. It was an old pretend GoPro I had, and it's obviously seen better days, but I didn't want to make it again. Hopefully this time you've had good audio and a decent picture quality. And I'll be really interested in your comments. Please keep them coming, let me know what you think. Some of you are going to think I'm absolutely wasting my time, but you know, that's up to me, it's my time. But I like the idea of being able to control everything independently and be in control of the whole thing, and this hopefully will allow me to do that. Okay, cheers for now, and if you like it, then please press the like button and subscribe. Thanks very much. Thanks for watching.